shit. How's it going, guys? So today we're looking at this bass face, which is a sound digital clone. It's just one of the Chinese sound digital clones, full bridge thing, 1500 watts, RMS at 1 ohms, nice and compact. No burnt FETs, so probably got a couple of output FETs shorted, maybe just one. Often sometimes these just kill one output FET randomly. So let's have a quick peek in here. No power supply FETs burned, so likely to be okay. Just check across the power terminals. Yep, no dead short there, so it looks alright. Fashionably late, yeah. It's weird when I click start streaming. If I click start stream and then navigate away, like if I click start stream and then minimize Firefox, it doesn't actually start streaming. I have to then look at it again for it to finish starting the stream. I hadn't realized, so I've just been sitting here talking to myself about 4 minutes. So let's have a quick look at this. Looking for output FET shorts, which there's none there. There's none there. Right, what's wrong with this thing then? Why is this thing in the workshop? No dead output FETs. No dead power supply FETs. That's usually the only real thing that dies on these, is just the FETs. So this looks like a pretty brand new amplifier in brand new condition, so not sure what's up with that. Let's plug it in, see if it works or not. So this is a bass face Team 1500. It's basically just a sound digital clone, same as the SFB, same as the B2 Riot, that kind of thing. It's just a sound digital clone, full bridge. Yeah, bass face is a brand we have over here in the UK, but it's the same as a lot of stuff you have over in the US, just under a different sticker, different brand. Scan Unbiased 30, how's it going? Yeah, you won't see it in the States. I mean, you will have seen this. You will have seen this amplifier, but it will have a different sticker on the front. That's literally all it is. So this is this exact same amplifier as the SFB, the Sundown SFB 1500, for example. It's exactly the same amp. It's just got a different sticker on the front. So no dead FETs in this one, it seems. Let's power the supply on and give it some juice. See what it's not happy with. First thing I'm going to do is probe the power supply MOSFET drain. Check we get some pulses on here. Yep, a couple of pulses, see that? And let's now see whether it's building rail voltage. We have, yep, about 30 volts worth of rail built just there. And let's check the speaker terminals, got a bit of DC on each one, that's correct, okay. Let's continue building rail voltage and see if we get any Class D switching on the low side. Yep. Beep. There we go. Okay, got Class D switching. Looks good. So there's nothing wrong with this. Plug some RCAs in. Make sure it makes audio. This only has one RCA input. The other one is an output. Same as all the other ones coming out from China. Got some dead FETs on the sound maggots. Heck. That sucks. Sorry to hear that, bro. But easily repaired. Let's get some signal generator turned on. 38 Hertz. Turn the gain to just a little up. This, I tell you what, this is one thing that bass face do better than Sundown. So, or any of these other brands. So you see on the EQ boost, they actually put a sticker over it to prevent you from just increasing it. That says read manual first. So I like that. What I would prefer is if bass face just got rid of this knob completely. But I like that. That's cool. I feel like they should do the same on these other knobs here as well. This low pass filter was turned up way too high, as was that subsonic. Although subsonic's probably better actually, but it depends whether these numbers on the side are actually accurate or not. A lot of the time they're not. So yeah, let's get it down. Let's turn it up a little bit. Low pass filter down at minimum. Do we have audio? Yeah, it's working fine, bro. Alright, nice easy first one, nothing wrong with it. Yeah, it's just going to be a pretty chilled stream today, guys. I'm working today anyway, so I thought I might as well just turn the cameras on, and you guys can keep me company if you're bored. If you're not doing anything on the Monday, or if you're working, then just have me on in the background, and if anything interesting pops up on the stream, then might be cool to see. But yeah, this first one, nothing wrong. All good. It's a shame that I had to break the warranty sticker. Do you use main ground as a reference to get the audio signal in these? Yeah, so basically my bench power supply shares a ground with my oscilloscope and my signal generator, so all the grounds are tied together in the workshop. That just means that when I'm probing stuff with the oscilloscope, I don't need to have this annoying ground wire hanging off and clipped on somewhere. If I need to measure very small waveforms that are very critical in shape, that I need the minimum amount of noise on them, then I will then float the scope and have a clipped ground reference on somewhere very close to the probe, like you should do. But generally, when we're reading high voltage waves like this, because obviously the voltage is very high, the wave shape that I'm looking at is large in relation to any noise that's on there, so it doesn't really matter for that. Okay, let's grab the next one then, seeing as that one was a no fault. Next one, probably going to be something similar. Got a bunch of stuff over here. I'm actually going to be moving the workshop. So not moving house or anything, but there's another room in this house that is a little bigger that we originally didn't use as the workshop, because the idea was, when we moved in here, I was thinking, okay, we've got a few rooms upstairs. So basically the workshop's actually upstairs in the house, which is really nice. I love it, rather than being an outhouse in the garden or something like that. So my thoughts were, okay, cool, if we're going to make a room in the house be the workshop, then it needs to not be a dual purpose room. So it needs to not be a room that can also be used as a spare room, because obviously being a workshop, it's going to get a bit messy. It's going to have solder fumes and, you know, just stuff in it that isn't really ideal to be used as a guest room as well. So the smallest room upstairs was picked as the workshop for that reason, because being the smallest room, you're not going to have this one be a guest room because double bed doesn't really fit in it. So yeah, that was the idea. The idea was to have this room be just a workshop and not need to be used for dual purpose, and the slightly larger room that we have available that's spare was to be used as a guest room. But turns out we don't have guests very often at all to stay over, at least not yet anyway. So worked out that we can actually get a sofa bed in this smaller room. That's not quite double size, but that's still fine, and it would be much better to use the bigger room as the workshop. So we're going to swap the rooms around. So at some point over the next few weeks, the room will look suddenly different, and I'll have lots more space, which will be nice. The only problem is this room, because this room was planned to always be the workshop, it's got carpet in it, of course, and the carpet is not in the best condition now, because it's had like soot from blown MOSFETs and solder and all sorts of stuff. You know, the carpet's not in great condition in here, so either going to need new carpet, or I might just put a big nice rug down to hide it all. This is actually a pretty nice looking amp. Okay, so here we go. Next one. This one says electrical fault. So let's have a look in here. Whoa. Base face, actually, they include enclosure designs and cut sheet with their subwoofers. So the Indie S line of subwoofers, which is actually quite decent. It's really good for the money. Yeah, they include a box design that works really well, and it's actually a fairly decent box. It's tuned nice and low. It's the right kind of size. It's not like tiny and tuned high like a lot of these manufacturer recommended boxes are. And this amplifier looks nice. It's not a particularly nice circuit, I don't think. We'll have a look, but it looks quite cool. Hello from Italy, yo! Hello from the UK, my friend. Mamma mia, it's a spicy MOSFET. That's my Italian impression for you. Just absolutely butchering it. How's your waiting list looking for amplifier repairs? At the moment, it's probably looking at maybe about a week for me to actually look at it. So from when the amplifier gets to me, it's probably about a week until I get it on the bench, and then depending on what's wrong with it and what parts I need, you're looking at a maximum turnaround time of usually about 2 weeks, which I think is not too bad. Oh, this is gross. This looked great from the outside. This is just one of the most shittest circuits ever. Sorry. I need to stop using the S words on the stream because the algorithm doesn't like it, and it's gonna, yeah. That's a new thing with YouTube. Have you noticed that? People that you watch on YouTube that you've been watching for years that will always used to swear, like Lewis Rossman, for example. Now, no one swears, everyone bleeps it out because of the bots that don't do the recommend and do the demonetize on the YouTubes. Gilius, Gusto Mera, hang on a minute, Meraviglioso, Gusto Meraviglioso di MOSFET. That's a big long word, that is. Sam, you got me super busy lately with your new video series. Oh yeah, nice. I'm glad you guys are enjoying it. The first video is doing quite well. Not quite as well as I expected, but it's doing quite well. But I think as the series picks up, the videos will hopefully start to do a bit better. I also made the worst possible thumbnail. Like, I literally made the shittest thumbnail ever for that first video. So I'm not expecting to do that great. I might need to make a new thumbnail. Yes. Look at this Meraviglisigo di MOSFET on this one. Look at that. So we have that one dead short. That one is not actually short. We're just reading the short of the other parallel FET. That one again not short. So we've got one dead MOSFET over here, and these ones are not Meravigliosos. So looks like we just need to change the output FETs on this one. And this board has such a low thermal mass, we can actually do this from the top of the board with no maleffects or any... There's no benefit to doing this repair from the bottom of the board at all, because the via conducts solder from the top and bottom in the exact same way. So it doesn't matter whether you solder from the top or the bottom, it's the same. And given that these boards don't have a high thermal mass, we don't need to get to both sides. Does anyone recognize this circuit layout from my previous videos and live streams? It's probably the most generic that you'll ever see. You will see hundreds of this board design dating back to the early 2000s in like literally hundreds of different brands. Hello from Poland. Yo! I can't do a Polish accent, I don't think. What is usually the failure point when an amp starts outputting noise like alt or ground noise through the vehicle, specifically if a customer arcs power or something with an amp powered on. It usually means that there's a ground trace broken inside the amp. So if a system suddenly starts making alternator noise where it didn't before, it means that there is either a ground trace or ground resistor broken in the amplifier. Look, broken in the amplifier. It means that, yeah, like either the ground trace to the RCAs or connecting the two power supply and output side grounds are open, dead trace or dead resistor, or in the head unit you could also have blown the head unit trace for the ground, or the Pico fuse if it's a Pioneer, or the RCA ground in the wire itself has gone bad, something like that. But yeah, the new series, I've already printed the box for episode 2, so the first submitted box. So that's going to be cool. It's freaking massive. So many of you guys are designing these absolutely monstrous boxes, like almost the size of the maximum dimensions I gave, which is great, cool, fun, but means that it takes like 3 days to print and like a bunch of filament. But yeah, it is what it is. I gave the dimensions at the end of the day. So, but yeah, I think a lot of people will. Oh shit! What the heck? I think a lot of people will be quite surprised at how small the box really needs to be. I think a lot of people are not really scaling things down from real life properly, and they're sort of looking at the thing and thinking, oh man, this box is going to be tiny, so they're making it bigger than it needs to be. But yeah, if you're unsure how big the box should be, or if you think your box is too big or too small, then design your box for a 12-inch sub, then scale the volume down by 216, like divide it by 216, and then that gives you the volume that your scaled box should be. But yeah, I'm getting boxes that are like 30 cubic foot for a single 12. So let's first of all remove the dead MOSFET. And with the other FET still in place, we're going to test the drive circuit is still okay. We're going to replace all of these MOSFETs anyway. There's only 6 RF 640Ns. It's literally pennies to replace these 6. So there's no point whatsoever in trying to save a buck and leaving the other bank of FETs in, even though they might technically still be okay. This is the same circuit layout actually that we did on the Can a live stream fix the amplifier, the most recent one I did, where I think it was what was it I did? Yeah, I think it was Can a live stream fix an amp, and I did exactly what people asked me to do, and there was a bunch wrong with the amplifier. It was a really fun stream. This is the same circuit layout as that stream that we did. If anyone remembers that, it was really fun, really good. Right, so that's the single dead FET out. So we're going to go ahead and check the health status of the drive circuit, and we can really easily do that. First of all, by checking it with a multimeter. So we've got a 557 one way and a 500 the other way around. I've got a feeling that might not actually be right. I think we might have drive circuit fault on that side, but let's just see, just out of interest. The amp looks pretty empty, like Rihanna's soul. Ooh! Burn. You can say Miss Ayik says you can say Znau 10 Spaloni MOSFET. It means broken MOSFET again. That first word, how do you say that? Znau. That's definitely not the correct pronunciation, because obviously different languages have different ways of pronouncing letter combinations. That's what it looks like. It sounds Japanese actually. Znau 10. No, actually that first bit doesn't. Znau 10 Spaloni MOSFET. What model of oscope do you use? I use a HP 54602B. There you go. I'm alright. How's it going now before you go? Good to see you on the stream. Hope you get better soon before you go. Alright, let's give this thing some power. See if we've got a drive circuit fault like I suspect we probably do. Although we might not. It's like a flip of the coin as to whether these things kill the drive circuit or not. This is low side, I think, over here. So if we get any DC at all on this side, then it's going to be toasted drive circuit. Might actually help if I put the remote cable in, mightn't it? It might actually help here. Right, guys, if you're not native, if English isn't your first language, okay, let's have some fun. Let's have some fun on this stream. If England isn't your first language, if English isn't your first native language, give me something to say that's quite funny in your native language, and I will try my best to say it and pronounce it. Right, is there any DC on this bank? Okay, so built a little bit of rail voltage, not got any DC on the drain, that's a good sign. Got negative rail there, positive rail here. Okay, we built a lot more positive rail than we have negative. We built 12 volts worth of positive and 6 volts worth of negative. That dissipates quite quickly. Could just be parts of the circuit using the negative rail and it dissipates quicker through there. So let's power it up fully and see if we get any switching on the low side over here. Yeah, okay, cool. Drive circuit appears to be in working order, so it just needs 6 new output FETs. Nice and easy. Nice, easy, chill back stream today, guys. I'm not going to be specifically choosing amplifiers that are like interesting or complicated to repair. Just trying to get some work done. Thought I'd jump on with you guys. Actually, a lot of the time, these amps don't actually have pull-down resistors for the rail voltage. So if you're working on an amp that looks like this, that has this circuit layout, you can't guarantee that if you go and make a cup of tea or coffee, that when you come back to the amp, it'll have no rail voltage left in it. This one does seem to be dissipating a little bit. You can see we've got 38 volts there, and it's going down by about 0.15 volts every second. It's quite slow. The negative rail has already sunk to ground, so that obviously has a low resistance to ground, some kind of resistor set up in here, part of the VCC circuit it's using. But yeah, the positive rail is very slow to dissipate, so bear that in mind. And some of these amplifiers don't dissipate at all. They don't have any pull down resistors whatsoever, so you can leave this amplifier for like a month, come back to it, and it will still have like 80-90 volts in it, so be careful. I just want to get my resistor load here so I can quickly short out those rails and continue working on it without getting a big spark. Alright, let's have a look, see what you guys are giving me to say. Sam, how the box video do? Not so great. What? No, okay. The Boom or Bust, the first episode, is doing okay. I kind of thought that maybe the Boom or Bust series would be like really super popular, which I think it might be, but it's only been the first episode, so I think it just needs to gain some traction. The video that I did on the Taramps versus JBL, that video is like freaking to the moon. Getting like thousands and thousands of views, which to be fair I expected that to do well, but I thought Boom or Bust might be second best, but it's actually third best at the moment, so we'll see. But I think it will take time for the series to pick up and to people to like really get into it and start seeing other people's designs and stuff. So yeah, we'll see. And also, I made, like I say, I made the world's worst thumbnail possible for that video, so I'm kind of blaming it partly on that. Hello, Kevin B. Sam. All right. Labadiana means a hello. Please say us the USB switch you use for changing the camera model. Oh, it's literally just the cheapest USB foot pedal you can find on Amazon. So go on Amazon, type in USB foot switch, and it's a set of 3. So it's a set of 3 pedals in one block. Just plugs into USB. And yeah, you can basically use it for anything you like. You can basically just sets the pedals as hotkeys, so you can assign it to whatever keystrokes you like. Say MOSFET explodat. G'day, mate. That's my native. Amplificador muy merida. Wait, mierda. Yeah, oh yeah, Spanish, isn't it? Amplificador muy mierda está quemando. In Arabic, el MOSFET fasdet. El MOSFET fasdet means the MOSFET gone bad. Currently about to take my new ATV for a ride after rebuild. Awesome. I hope it goes well, man. Stay safe out there. If you just rebuilt something, I'm always skeptical. Like if I ever rebuild something for myself, or you know, I'm always like, ooh. Like also, especially with amplifiers as well. So if I'm rebuilding an amplifier for my own use, for myself, I usually just use like spare parts I've got laying around the workshop, like I did with the Terramps HD10K. So whenever I power those up and use them, I'm always like, yeah. So I don't trust the MOSFETs are okay in them because they're used ones. Custom repairs always get new parts, obviously. Sam, what do you charge per hour? It really depends, man. I don't really charge per hour as such. It's more depends on what is wrong with the amplifier, how complicated it was to diagnose, how much the parts cost. I can't really charge per hour because sometimes I'll spend ages, because I'm very stubborn, right? So I'll spend ages trying to find a fault with a small cheap amplifier that doesn't cost much. If I did it based on the hourly rate, that, you know, the repair would cost 4 times the cost of a new amp. So yeah, it's difficult. I don't really do it by the hour. It's just I sort of base the cost on what the amplifier is, what the amplifier is worth, how complicated it was for me to diagnose that. And what the parts cost, and also I base it on what the customer's probably willing to spend. Like, you know, if the amplifier only costs £300 new, then I can't really charge like £280 for a repair. So I might make less on an amplifier like that, but at the end of the day, any money is some money, so I'd rather repair it than not repair it and get a bit of money than none at all. So yeah, the hourly rate probably varies hugely. people from Poland say I was paid for that video. No, that's a shame. I tried to make it as unbiased as possible. This full disclaimer, nobody pays me. I wish they did, but even if people did offer to pay me for like making content be a certain way, I wouldn't accept it anyway. But yeah, I definitely don't get paid. No one pays me. But I would love them to pay me, and if they paid me, then I would still make balanced content around whatever it is. Like I wouldn't make lies, I wouldn't make the video look a certain way when it wasn't. Like if Terramps, for example, let's say Terramps reached out and they paid me and they were like, oh hey, we want to pay you to make a video about the new range of amplifiers, blah blah, and if they said, hey, we'll pay you nicely if you know really big up this product, and if you compare it to another amp and make it look like it's better than the other amp, I would say no, sorry, I'll will take your money and I will review this product. If it sucks, then I will say that it sucks. I have been sent stuff before for review. Although I haven't been paid off, I've been sent stuff for review before that I have made it quite clear as to my feelings on it. For example, the Digital Designs M series amplifier review. If you actually read that, if you listen to that video carefully, you can tell that I actually don't like that amplifier and I'm not really recommending it. But I'm trying to do it in a balanced way to, you know, anyone that really likes DD and they want to buy it, they can. But that video wasn't singing the DD's praises, even though you know, I love DD and I was a big fan of DD for the longest time. But yeah, didn't go out my way at all or to try and make DD happy or whatever to make that video be singing its praises. I made it quite clear that there's much cheaper options out there. This amplifier is nothing new. It's based on 20-year-old tech, and they say it's something new on the website and it's not. So yeah. Okay, cool. No more rail voltage. That's good. Following your advice, I ordered a Tyrant Smart 3. Nice. You think it's wise to void a warranty, just open it and secure the components better against vibration? To be honest, those amplifiers are actually very well built already. You don't really need to. There's not much extra strength you could add. The components are pretty well seated down anyway. Saying that, Tyrants are very good with their customer service. So even if you did open the back and you broke the warranty sticker, I don't think they're going to say that you can't have a warranty if there's an actual warranty issue with it. So I don't think that legally stands anyway anymore. Like, breaking a sticker doesn't mean that you don't have warranty anymore. That's not a you know, that doesn't stand legally. So if you want to, then yeah, sure, open it up, add some strength, you know, in there with some silicone sealant or whatever. But I don't think you need to. They're pretty well built. Is there an option to compare output voltage using O-scope without a differential probe? What do you need a differential probe for in this case? Say, mie set ientrap. That's Surinamese for I repair amps. Mie set eindtrap. Eindtrap. Mie set eindtrap. I repair amps. Iot un stolz. Iot un stolz! Loud and proud in German. Nice. Yeah, I'm from Poland. Colder guys here are stubborn and AF and won't change their mind about Korean apps no matter how much I try and prove them wrong. Meanwhile, I'm unpacking my Smart 3 right now. Nice. Yeah, it is a thing. It's very difficult. People hate change, and when something seems too good to be true, then people often think that it is too good to be true. And I'm not going to lie, Tyrants don't do themselves any favors in the presentation of their amplifiers. Not going to lie, like they don't feel like the most premium, well-designed things. Like when you compare them to something out of Korea, they're much lighter. Well, obviously because they're smaller, but the potentiometers are all kind of plasticky and a bit crap, really, to be honest. And the input terminals have been quite small and stuff. The fans are loud. Like, it doesn't feel like it's going to perform well. It feels like something that's going to be a bit gutless and not really. It feels like that. So that just further re-emphasizes people's impressions on what this kit is going to be like, which is a shame. But yeah, so it is very difficult. If someone's got a idea in their mind as to how something is, how something performs, how something behaves, then it is very difficult to change their mind. I have plenty more videos where that came from, by the way, and well, I don't know how they're going to go. I don't know how they're going to go, but maybe I'll let you guys into a little video idea that I had a while ago. So I would love to enter a SQ competition twice. Okay, I'd like to go and enter EMMA, for example, EMMA, here in Europe or the UK. I would like to enter it twice. I'd like to enter it first time with some really nice amplifiers. Genesis, I don't know, you know, just yeah, really good like SQ kit, SQ amplifiers, like well respected stuff. So obviously SQ judges see the system, they see the install, see what kit's being used. So in their mind they've seen what kit's being used and they judge the car based on that. Then I'd like to go and take the car around the corner, swap the amps, okay. But the amps that I swap them with will be the exact same amps, but inside the boards will be something like Taramp, Stetson, something that is deemed never to be used in an SQ. And I would obviously make sure that these amps that are actually like sounding good and don't have like ridiculously high noise floor and stuff like that. But I'd love to swap the boards out for something that is deemed like never could be used in SQ. But in heat sinks that are SQ heat sinks, like, you know what I mean? Run the car through the competition again and just see what, if anything, if there's any differences in the scores that I get from that competition. Another idea similar to that would be actually to run the car through the SQ competition with the nice SQ amplifiers, okay, but then do it the other way around. Go run the car through again, but instead of putting like Brazilian boards in SQ heatsinks, I would put SQ boards in Brazilian heatsinks. So I'd actually be using the same amplifiers that I used for round 1 of my competition. So the same boards. So like, for example, let's say I had a Genesis 4-channel on my front stage, okay. The second time I go through the competition, I'd still have a Genesis 4-channel on my front stage, but it would be in a Taramps heatsink, for example, to see whether the judges put any kind of put any sort of like visual thing of like they've seen that it's a Taramps, they think that it's a Taramps amplifier, therefore when they then go to judge the system, are they then putting any of their thoughts and ideas about how the Taramps must sound onto how the system sounds? Be interesting to see whether they judge the Taramps system lower than the Genesis system, even though they're the same boards, same amplifiers inside, just because the case looks different and stuff. So I'd love to do something like that where, you know, something isn't quite as it seems, and just see if it makes a difference. Yeah, it'd be really interesting to test that. Do you mod amps for customers? Yeah, happily will modify amplifiers for customers, but to be honest, a lot of the time, making a modification to an amplifier is actually more expensive than just selling the current amplifier and buying an amplifier that fits whatever the customer's requirements are in the first place. For example, making a 1 ohm amp 2 ohm, it's cheaper to sell the 1 ohm amp and buy a 2 ohm amp than it is to modify them, you know, to change the impedance. When's next Boom or Bust? Probably going to be Friday or Saturday. I'm going to try and make Boom or Bust be weekly. I can't guarantee that, but I'm going to try and make it be weekly. So I've already printed the next box. First viewer submission. It's going to be interesting. Yeah, if you're keen on Boom or Bust, then probably Friday or Saturday. I had a question about boom or bust. Would it be okay to use small ABS pipes for ports rather than printing them? Or should they also be part of the print? Everything should be part of the print. The reason for that is printing out your designs doesn't take up any of my time, and it doesn't really cost a lot of money. If I have to start buying extra things like ABS ports specifically just for one design, or perspex tops, or just anything that I have to buy extra, that not only adds significant cost to each enclosure, but it also adds significant time. The idea is that I can just kind of have these designs, have these enclosures printing once a week, you know, in the background while I'm working on stuff, and I don't have to really, you know, spending any more of my time on them. But we'll see how it goes. Like at some point in the future, if the series really picks up and it's really lucrative and it's like my main thing, then yeah, maybe each box, you know, you can ask to have specific different materials inside or something like that. But to be honest, if you needed like parts gluing into the box, like if you wanted ports that were a weird shape that wouldn't print so well in the box, then by all means design the ports to print separately, and I will happily then glue them into the box to make a final box. You can have the box designed in kind of segments and have it assembled together, have the port designed and you know, assembled separately, and I'll glue it in. That's fine, not a problem. Yeah, there's been some really interesting designs sent in. Actually, it's kind of like a bit of it's kind of 0 to 100. I'm either getting very basic designs, which are cool because it's going to be interesting to test like the current normal style boxes, like slot ported and sixth order and stuff like that. I'm getting very normal boxes, but then I'm also getting some really crazy out there designs that it's, you know, that they're like, wow, sure, not sure how it's going to work, but let's just see how it goes. So yeah, it's interesting to see what you guys are coming up with and sending in, and I think it's going to be really interesting. Maybe in a bit, maybe once we finish this amplifier, I'll show you some of the designs that have been submitted. Would anyone like to see some designs that have been submitted so far for Boom or Bust? Would that be interesting? Okay, let's have a quick look at some of these chats. Anyone have a list of the Sundown SFB 8K unmarked components? Yeah, it's probably going to be the 8K. It's probably going to be using IRFB 4227s in the output. The power supply is going to be IRF 1405. No, IRF 1404. IRF 1404 in the power supply. You can also use IRFB 3077 and like a host of like IRFB 7537 as well, 7530. You can use a whole range of power supply FETs. It's not fussy, but yeah, the output section 4227s or similar. And the drivers are IRS 20957S. Oh heck, this one looks complicated. Wait, nap raw em naprium was mac nia kaze naproyam was mac was Was Magnia. Means I repair amplifiers. How do you pronounce this kind of CZ together? What does the CZ make a sound for, and the WZ as well? Because obviously, the English thing would be was, or like kz. Can't call it premium, plasticky knobs, no protection in the box. Yeah, that's exactly the thing. See, these are great circuits, but they're not really presented well, which is what kind of solidifies a lot of people's pre-thoughts about how they must perform. It's about Brazilian circuit. If I have to check the offset after output driver replacement, if I want to get much more accurate readings with an oscilloscope instead of multimeter DC off, you can use your oscilloscope. Just use 2 channels. Just use a 2-channel oscilloscope. Or if your oscilloscope is not referenced to the main ground, like if your oscilloscope is battery powered, for example, then you can connect the ground probe to a terminal that has some voltage or waveform on it, and the scope will use that as a ground reference. You don't need a differential probe for that. The only time you need a differential probe is when you're trying to use part of the circuit as a ground reference, but your scope is also grounded to the same ground as the device you're trying to test. I think that's how that works, and you don't want to float your scope or something like that. Giant soldering line, yeah. Hexabase just dropped a massive knowledge bomb. Has he just released a new video? I need to go check that out. Yeah, let's check out Hexabase's video after the stream, guys. After the stream, go watch Hexabase's new video. What's your opinion on Steg amplifiers? From the couple that I've seen, they have had a really interesting circuit design. Yeah, seem really nice. They're not generic from what I've seen. In-house circuit design by the looks of it, and nice build quality. A little overcomplicated, perhaps. Lots to go wrong, but yeah, seems pretty nice. You should add smoke and LEDs on the boom or bust so people can see the air moving and show how the orientation of the box changes it. That's not a bad idea. I do have a smoke machine. Yeah, I've got LEDs in the box anyway, so that could be kind of interesting. Although I've only got one Perspex side panel, so hopefully you'll be able to see the smoke moving around in there. But maybe I'll try a smoke test in the box just to show how it kind of flows around. But it might be interesting to see. So the reason I have the giant soldering tool is just because when I'm working on some bigger amplifiers, removing the terminals and stuff like that, it's really useful to have a powerful soldering iron with a high thermal mass. And I already had it heated up, so I usually use this smaller soldering iron, but I had the big one heated up anyway, so I thought I might as well use some of its energy that it's already used to suck the solder from those holes. CZ is pronounced kind of like ch. Oh, okay. Oh yeah, Czechoslovakia has the CZ, doesn't it? Ch. Okay. From your experience, what have been the outcomes from an amp speaker wires not connected to a sub, either plus or minus touching battery terminals? You're going to have dead output MOSFETs, and you're going to maybe also have drive circuit faults, and so it depends on which one. Depends which one it touched, and it depends whether the amplifier was a half bridge or a full bridge. If it's a half bridge and it touched the positive, you're going to have dead output FETs. probably, and maybe some drive circuit faults. If it's a half bridge and you touch the negative, then you might be okay. You might have gotten away with it, or you might have a blown ground trace in the amplifier somewhere. If it's a full bridge, then you're going to have dead output FETs regardless of which terminal it touched. Yeah, Perry Babin is freaking awesome. His guide basically helped me get to where I am today. If it was on a full bridge, then yeah, definitely. If it's in protection now, then you killed the output FETs. One, two, three, four, five. 6. I've left my thermal paste downstairs, god dang it. Okay, that's fine. We'll just take it straight out the tub. Someone said you could experiment with a checkerboard insert opposite the perspex if the smoke won't show. Oh, because the checkerboard will provide a non-uniform pattern that you're looking at the smoke through, so therefore you should be able to see its movement easier. That's actually a very clever idea. Yeah, I like that. I might give that a go. And this is not how I usually apply thermal paste, by the way. I've left my squeegee thing downstairs. I was doing some PC work. Do you ever use thermal tape? I like it better. Yep, sometimes, but it's very expensive. Thermal tape is very expensive. But these amps already have thermal pads, right? So if I need to replace the thermal pads in an amplifier, either the Capcom tape or the SILPAD 900 or something like that, then yeah, obviously have to use some. But usually, most of the time, 99% of the time, the thermal pads or whatever kind of insulation material isn't damaged at all. So there's usually no need to replace the thermal pads or anything like that. Thanks for the sub, Devastator Audio. Appreciate it, buddy. Are you still working on the audio pipe amp? I've still got it here. I wouldn't say that I am actively working on it all the time, no. I put it on the back burner for a while, just because it takes up a lot of time and I've just been really busy. Like the audio pipe mod is one video, so I've been working on trying to build up this new video series, Boom or Bust. I've had loads and loads of amplifier repair stuff for customers come in, so I haven't had a massive amount of time to work on like my own stuff or like the stuff for one video, but it's definitely getting done. But yes, it is taking a long time, I know, but I do still have it here. But yeah, I haven't actually worked on it in a long time. It's almost finished. Like I just need to wind the secondary on the transformer and put it back in the heatsink and test it. That's literally all I need to do. I just need to buy some copper wire, which I actually have done now. I've got some copper wire on the way that's the right kind of thickness and stuff, so I should be able to get the audio pipe mod sorted over the next sort of like month or so, I reckon. See how it goes. What's up, John? How's it going, buddy? Thanks for jumping on. I hope your appointment goes okay, Jesse. Thanks for tuning in for a little bit. Shannon says, I'm sure just a noob question, but are you not worried about using an ESD strap? No. No. Go and watch the video where Linus Tech Tips and Electroboom tried their absolute very best to damage a much more sensitive electronics components than these with ESD, and they really struggled. Yeah, ESD is not something you need to be concerned about when working, especially not when working on components like this. These are very rugged, large-scale, like semiconductor components. You know, if I was working with extremely delicate chips that use like a 0.5 1 volt VCC, tiny little dies or whatever, then maybe I would be a bit more concerned, but still not really. The resilience to ESD in electronic components has absolutely skyrocketed since it was a problem, you know, maybe in like the 70s or 80s, where parts would die if you touched them and stuff. But yeah, it's a really good video, that actually. Electroboom with LTT, where they try and kill stuff with they actually have like an electrostatic what's it, like an ESD gun. It's a gun that like just continuously gives static shocks to stuff, and yeah, they really struggled to kill. I think they did kill one thing. I think they killed something, but that was it. And that was with like an actual electrostatic gun making like visible sparks continuously off of stuff. Good thing amps don't use liquid metal like PS5s. Heard lots of problems. Yeah, I'm quite surprised at that, to be honest. I didn't think that the PS5 would use liquid metal. One of my computers had liquid metal in it for a while, but yeah, it just ate away at the heatsink plate. In PC motherboards, we must wear them. I strongly disagree, Shannon, I'm afraid. If you go watch that video that I said, Linus Tech Tips versus Electroboom, they tried to kill motherboards, computer components, etc., and were ultimately really unsuccessful. I think they killed one thing, but I think it was a bit of a fluke. I have always built my PCs just like on the carpet, on the floor, never strapped myself to ground or anything, and never had a problem. And as have thousands, literally thousands of other amateur PC enthusiasts, people building their own rigs in their bedrooms and stuff from the age of like 12. It's a very, very, very low risk. But I guess you can't be too careful, so if you want to strap yourself to ground, then sure, no worries. But you want to make sure that you're doing it safely as well. You don't want to strap yourself directly to ground without any resistance, because that then puts you at a huge risk of getting electrocuted. So if you're going to ground yourself for ESD reasons, make sure you're grounding yourself through a high enough resistance that you're not going to get a shock if you do touch something live. Or for your company. It makes sense if it's like a corporate thing, I guess, like you might as well cover every base. you might as well, you know, if it's a company thing, if there's even like a 0.5% risk of something happening, if you're doing things on a large scale, then that 0.5% might end up turning into a handful of, you know, failed components, lost money, then it didn't need to be. So I can understand that. Or like let's say, for example, you're working on data recovery and it's like, you know, customers' sensitive data. Even that 0.05% risk of ESD causing damage, you don't want a single customer to not have their data back because of a fluke 1 in a million chance of ESD damage. Like, you just don't want to risk that. So yeah, it makes absolute sense. David said, amps often have liquid metal in them, but only for a brief minute. Yeah. Under failure mode, yeah. Which amp are you repairing? This is just some piece of shit base face. It's a generic Chinese half bridge. It's probably about 600, 800 watts, something like that, this one. I had minor surgery on Friday. It's done. I need to see a nurse every day. Well, it's cool. They're obviously, you know, keeping track and making sure everything's going okay after the surgery. So yeah. Are you still going to show us boomer bus submissions that don't make it to the print? I don't know. Maybe. There are a few that have been submitted so far that I know for sure I won't be doing. Only because I know that they will perform terribly and they will take a long time, a lot of money, energy, and material to print. So there's a couple that I'm like, I'm not gonna. I don't want to do that. It's just gonna. It's not going to perform great, and it's just going to take so long and so much material to print. But I've let the you know, anyone that sends a design in, I've replied to all of them, and yeah, I'll say, hey, look out for your design in the future, or I'll say, hey, great design, looks interesting, but I'm not sure that we'll be doing this one for these reasons. Unless I start getting hundreds of, you know, submissions a day where I can't keep up with it. But yeah, pretty much anyone that sends in a design, I sort of like give some feedback on it. What is an example of your current favorite amplifier? What makes it your favorite? Board layout. That's an interesting question. Not necessarily meaning favorite circuit design, but board layout. I'm going to take that question literally. So the one that I can really think of that I really loved the layout of, and I really loved the thought process behind, and the things that were included in the circuit design and the, you know, the actual layout process, is the Powerus. That video I did on the Powerus amplifiers. I absolutely love every single design choice that was made about that circuit layout, because it's designed to be repaired. That Powerus board, even though it is really well designed, really great amplifier, great parts, great build quality, so it should have a pretty low failure rate, but it's designed to be repaired. Love that. It has really useful stuff on the board, not only labelings, but also useful traces that can be unbridged and reconnected again, just with solder, for example, to disconnect the main rails from the output side. Lots and lots of really useful stuff when it comes to repairing the Powerus boards, and I love how well assembled they are and stuff. So show the 3D rendering and explain why they didn't cut it. Make filler episodes. That's a great idea. Taluko 16. That's a great idea. Yeah, for sure. Maybe like once a month, once a couple of months or something, or maybe maybe at the end of every season, I'll do designs that didn't make it, and I'll go through each one and say this design is this, and I'll explain why I didn't do it. yeah, that could be a great idea. I'm surprised I haven't gotten into fixing consoles. PS5s have lot fuse power related issues, a scope points right to bad parts. I've done Nintendo Switches in the past, but yeah, I don't know. Just I've never really thought of getting into consoles, but I guess I could do. Wouldn't be a bad shout. What's your opinion on Rockford Fosgate amps, the Prime Series? The Prime Series are generic board layouts, but you probably will end up paying more for them because it says Rockford on the front. I think if you're going to buy a Rockford, then buy one of their own board designs. You know, if you can't afford one of their own board designs, then don't buy Rockford. Buy something else that's the same board design but that's cheaper. These fuses don't feel very sturdy in here. Just making sure that they're making a good connection. There we go, it's a bit better. So yeah, it should still just work exactly the same as it did with the other FETs in. Let's just power it up and double check. Ta-da! There we go, output switching. We have 0.6 amps worth of idle current draw. Let's crank it up. 12 volts, 55 volt RMS wave, and yeah, 14.4 volts, 66 volt RMS switching wave. Nice. We'll check for audio as well. Plug an RCA in. Signal generator on. Talking about Paros, the Chinese have now copied the amp. I see some factories on Alibaba have them for sale. Really? Did not know that, Niresh. I'll have to check that. Send me a link to one of those. That'd be interesting to see. Could you do a video on how to replace Tinsel leads? I've got 3 bass face subs that have them too short and will break when powered properly. Ah, that sucks, man. It really depends on how the sub is assembled, what glues are used and stuff like that. There's not going to really be a one-size-fits-all video on how to replace the Tinsel leads. It's also a nightmare of a job. Like, you need to be really skilled in sort of understanding materials, their compliances and stuff like that. I'd say just get a recone kit, honestly. I'm all for repairing things, but yeah, replacing the Tinsel leads just definitely sounds like an absolute nightmare for someone that hasn't really worked on rebuilding, reconing subs and stuff in the past. There we go. There's a nice audio wave. Yeah, working well. Rip, up to clipping. Cool, that's that one done. What's your, oh yeah, it's not already. Paros parent brand Causus make some super freaking nice amps. You know what? I don't think I knew that. I don't think I knew that Causus was the company behind Paros. That's cool. That's really cool. Thanks for that. I've seen Causus boards. I've seen people have sent me. I haven't seen them in person, but people have sent me pictures of Causus boards before, and they always look like they've been put together in the back of someone's garage. They have a very like home built appearance to them. But yeah, if that's the case, then it seems like those guys know what they're doing because they're pretty nice amps. Did you ever work on a Bowland audio amplifier? Not to this date, I haven't, no. If we don't get them in the UK, that's probably why. So can anyone send an amp for repair, says Hammerback. If you're in the UK, yes, you can. If you're in the US, then it's going to cost you too much in shipping. It's not worth it. Alright, the next one's probably going to be interesting. The next one's going to be a bit of a beast, I think. Probably all the amps we're looking at today are going to be this Bassface brand, because they sent me in like a box of like 5 or 6 of them. So okay, that's 2 of them out the way so far. Let's put that back in its box. Thoughts on Stetson? It is a bit of a mixed bag. A lot of these Stetson bigger amplifiers that I have seen have, the circuit design is okay, but the build quality has been horrendous. I'm talking about the export line specifically. However, the new Evo, I think it's the Evo X line, has actually improved a lot on the build quality. Haven't seen a lot of them in for repair. I've repaired the odd 1 or 2. Very similar to Sound Digital. They're very similar to Sound Digital circuit design. So yeah, kind of hard to say really. However, the Stetson smaller amplifiers, like the little sort of like 1000 watt, 3K, 2K, 2.5K amplifiers, and specifically they're very sort of full range. What do they call it? I think they call it the is it the SQ? No, what do they call it? HQ series? There's a series of amplifiers they do that are mono, and I think they're 4 ohm stable, like 1600 watts RMS. And they had the highest switching frequency that I think I've ever seen, about 800 kilohertz on the Class D side. I was like, wow, that is pretty awesome. So they're going to be relatively nice sounding Class D amplifiers, provided they did the other stuff correctly, compared to a lot of the other Class D full ranges that you'll see on the market. So I think with Stetson it's going to be hit and miss. It very much depends on the model. Some of it has not been great, some of it's been pretty nice. But they're smaller amps, definitely are absolutely fine. They're very good value. Their smaller amplifiers are very cheap compared to the same offerings from Taramps and stuff. So yeah, if you want something nice and easy, nice and cheap and efficient, sort of like round the 1000 to 3000 watt RMS mark, then yeah, maybe give Stetson a look. Right, so let's have a look at this beast then, shall we? Whew. So this is the Bassface Team 15K, I think. Yep, Bassface Team 15K. So this is basically the same as the Sound Digital. I don't know what model Sound Digital call it. I think it's a 12K. Or no, I'll tell you what this is similar to. This is very similar to the B2 Riot 16K. Very, very, very similar. Exact same circuit layout. It might have 1 or 2 less FETs on the output side, power supply side, etc. But yeah, this is basically a B2 Riot 16K. Or a SFB. Did SFB make a 15? Is it a 12K? Yeah. It's one of the largest powerful bridges that are the Sound Digital clones. So this one's going to be an expensive repair depending on what's gone wrong. I have a trauma concussion series, needs repair. How bad is shipping? I think shipping from the States, you're looking at about a $300 round trip. So that's just for shipping, obviously not including the repair bill. I think the main issue with that is that there are import tax and duty fees, both on my end and probably on your end as well. I think it's like, I think the shipping itself would cost about $100 each way, and then you've got the import tax and duty, which changes depending on how the customs import officer's feeling, I guess. So yeah, it could be $300 to $350 round trip just to get it here, and there's no need for it. You guys have very capable amplifier repair technicians over there in the States. All you need to do is ask on the Facebook groups and people will send you in their direction. Oh, 13.5K the SFB, yeah, that's probably what it is, yeah. This one might have slightly higher rails than the 13K. But yeah, as you can see, basically, it's basically the SFB or the Riot or the GZCA or whatever all those other ones are. Have you ever heard of Synergy Audio? I've heard of them, but never repaired any of their amps, I don't think. Stetson 3.3K3 EQ, I ran for a while, quite liked it. I think, oh, the EQ! I think the EQ series is the one that I looked at that had a ridiculously high switching frequency, so yeah, that was pretty cool. What's your opinion on the Vibe Edge mono amps? The newer ones are, again, very similar circuit design to this that's been cloned, but yeah, it's the same as the base phase circuit, so I think the base phase circuit is cheaper. I'm not a big fan of Vibe and Edge, so go for whichever one is cheapest out of all these brands that are using the same circuit. There's no benefit to buying the more expensive brand over the cheaper brand. They're all exactly the same. They haven't done any R&D themselves on these boards, so... What could cause a short on the rectifiers? Rectifiers, right? This is one thing that often new technicians get wrong. So let's have a look at this amplifier. So you'll see myself and other technicians getting a multimeter, checking for dead MOSFETs like this. Okay, oh yeah, that's fine, that seems fine. Okay, cool, cool, cool. So we check for dead MOSFETs like this, and then they'll see us doing this, and then so you might do the same. And when you get a dead FET, it'll do this, and you're like, oh, it's dead. Well, actually, this one here is a rectifier. Now, when you probe, usually legs 1 and 3 of a rectifier in a Carly amplifier, you're not actually reading the rectifier. You're reading the transformer wind. So naturally, when you put DC through a transformer, it's a short. So we're just reading the transformer wind. So it'll look like a short. The only time a rectifier will be dead is if it reads a short between 1 and 3, 2 and 3, and 1 and 2. If all of the legs are shorted together, then it's a bad rectifier, very rare to have. But if it's only 1 and 3 that are shorted, or only 2 and 3 or something, for example, if it's a different layout, different setup, then it's fine. Oh, Stetson does not have an Evo X lineup, that's the SD. Oh, what's the Stetson one called? It's not Evo X. What's it called? I did one recently, not that long ago. Stetson. They look very similar. They're like all black with like a red. I think they got red branding. I can't remember. Very similar though. Very similar looking, similar name. But yeah, anyway. So let's have a look at this then. So I didn't come across any dead FETs yet. So we have full bridge amplifier and we have 2 banks of outputs. So we're going to have low side here, high side here, low side here, high side here. So we've not got any shorts on any of these banks. Seems okay so far. That's actually a bit of that's a bit of a relief, but also a bit disappointing, because it's a relief because it means that this amplifier is probably not going to be like a huge amount of effort to repair, because none of the FETs seem to be shorted, so it's not going to, you know, cost like a load of money and parts and all that jazz. But it means that the repair bill that I can make for this amplifier is not going to be very much. So let's hope that it's going to be a relatively quick repair. Okay, no power supply FET shorts either. That's just discharging the filter caps. Wait for that to climb back up again. Yep, so that's just charging the filter caps both ways. Okie dokie. So let's get this thing powered up then and see why it has made its way into my workshop. The really important thing about these amps when powering them up, it's more important on these than with other amps, is to absolutely make sure you have a load on the speaker terminals when you power them up. The way that the inductor and the filter network in these amps is set up is very unstable when there is no load connected on the amplifiers, on the terminals. What can happen is that spontaneously, seemingly at complete random, the inductor filter can break down. By that I mean that it stops becoming an inductor and just presents itself to the circuit like a short piece of wire. And when that happens, the Class D switching wave gets sent straight into the filter capacitor, which obviously passes it through to ground because it's a capacitor and it's high frequency, killing the FET. So what happens is the MOSFETs here have a massive big square wave on them. They have a switching wave that's maybe running at like 150 kilohertz, for example. So it has switching wave plus audio. They're both overlapped on each other. Obviously, you just want the audio. You don't want the switching wave. The switching wave is how Class D works, but you just want to get the audio out. So what happens is the audio and switching wave combined get sent through this inductor, and I think it's on this one. I think it's these capacitors here. So what the inductor does is it acts as, it has inertia. So it filters, it gets rid of the high frequency wave, leaving only the lower frequency audio wave. But in order for it to do that properly, it does need to have a pathway to ground for the high frequency wave. So the capacitor acts as a pathway to ground for the high frequency wave, but the low frequency wave is too low. The capacitor doesn't pass it, it just kind of blocks it and sends it to the speaker terminals. So what happens is, because these output filter networks are very unstable, if the inductor stops presenting itself to the circuit as an inductor and just presents itself as a piece of wire from the MOSFET to the capacitor, then that high frequency switch wave is not filtered. Therefore, it passes straight through the capacitor to ground, killing the FETs. So really important, you must have a load connected at the speaker terminals, and that helps to prevent the inductor from breaking down and not actually filtering properly. Sam, can you show live DC offset adjustment with this amp and in which input voltage it's done? Yeah, sure, I could do. Have a look at what potentiometer it is on this amp. What's the worst repair you've ever had to fix, and have you turned down anyone because of how bad it was? I've turned down a very small handful of amps. I could probably count them on my hands here. The ones that I know from memory that I've turned down are heavily water damaged amplifiers, and the reason for that is because water doesn't just kill components. Components on an amplifier, relatively easy enough once you get used to it to track down and replace. Water damages traces and, most importantly, vias. If you've got an amplifier that is quite a complicated circuit layout, especially if it's multi-layer board, and you've had it sitting in water and that water has corroded and eaten away at all of the traces and vias, then you could easily spend like 10, 12, 15 hours or more going through every single trace and every single via on that board through the microscope, resoldering it, boring it out, reconnecting it, and you still might have not have caught every single one of them. You might still have missed a couple, and even if you spend a few hours, get the amp working again, there's nothing to say that the amplifier will continue to work, because the corrosion still happens afterwards. Even after you've cleaned it up, you have weak traces, weak vias and stuff, and it might just fail again very soon. So heavily water damaged amps, no, sorry, you're buying a new amp. Or heavily fire damaged amplifiers. I've had some amps that have come in with really bad fire damage as well, and I have actually repaired some fire damage amps that have been salvageable, especially if it's a power supply side fire. Power supply sections are very simple. There's not a bunch of traces going everywhere and stuff. You can quite happily rebuild with like jumper bars and wiring and stuff like that. You can replace the missing traces for a power supply section fire. Yeah, if it's an output section fire, then it's still doable, but it's a bit more complicated, and it also just doesn't look nice and maybe less reliable going forward because the traces are now different lengths to what they used to be. Circuit's a bit out of balance in the resistance of the traces and stuff like that. So yeah, just a couple where I've turned them down. Have you ever worked on an old school Soundstream XXX 1500 dual mono? I don't think so. No, not that one. I've worked on the Soundstream. Oh wait, maybe I have. I've worked on a really old big ass Soundstream that was very similar. It was basically a Lanzar Opti. No, yeah, actually. No, you know what? Eat, Sleep, Base, Repeat. I think I have. Yes, I have. It's basically two Lanzar Opti circuit layouts in the same on the same PCB. It's like yeah, it's basically two Lanzar Optis strapped on the same board, from what I remember, with more powerful MOSFETs on the board. What's your opinions on substitutions RFP 1405 and 4242? Now, RFP 4242 are going to be very hard to replace. The only real replacement that would drop in and work in terms of its power and stuff like that is probably going to be the RFP 4868. However, that MOSFET is very hard to drive. It has massively high input capacitance. It's quite a slow MOSFET, and in order to get that to work correctly, you might have to run some 4148 diodes in parallel with the gate resistor if the amp doesn't already have them. If it does already have them, give it a go. Drop in some 4868, see how it does. But they're very expensive MOSFETs, and if they don't work, then that sucks because that's a lot of money that you've just wasted. I haven't tried, I don't think, those. Oh, actually, what did I do? I think I did have to rebuild the output section of one of those amps. I can't remember what FETs I used. Did I use 4868s or did I use something else? I can't remember. It was a long time ago. Wet Dookie, nice. Yeah, Nintendo Switches are fiddly to work with. I've done Nintendo Switches before. Yeah, the charge ports and stuff. Yeah, definitely doable with a hot air gun. Nice. Glad to see that you were able to do that. In the UK, we have 240 volt mains. Does that make power supplies easier to power? It does help a bit with power. Obviously, the power is the same because in the States you have 120, but your current is higher. But it does mean that we have less voltage drop across mains wiring and stuff, and it just makes power supplies a little bit easier to design. Higher voltage, lower current, need less thick wires and stuff. Yeah. What's your opinion on Synergy Audio? I don't know. Don't have them in the UK. Never really seen their stuff. I don't have any opinions or thoughts on Synergy Audio because I haven't seen their stuff, so I can't comment on it. Sorry. Right. So this amp is now all hooked up. Actually, I need to. One last thing I need to plug in is the remote cable, and then we're good to power this thing up and see if it's working or not. It doesn't have any dead FETs or anything like that, so I'd be interested to see why it's here. Do you get many USA repairs? No, I don't take repairs from overseas because the shipping costs too much. It's not worth it. There's generally always a good technician in your country, and if there's not, then it's probably cheaper to buy a new amplifier. Okay, power supply is on. I'm going to start with the voltage nice and low. The rail voltages in these amplifiers are quite scary, so eye protection going on, as always, with these big amps. Although the rail voltage in these is actually half of what it would be in a half-bridge version of an amp like this. So let's see whether we have Class D switching or not, first of all. So let's turn that down a touch more, about 10 volts. Yeah, 10 volts going in, nice and low. Should keep the rails down a little bit just for safety, in case there is a problem. Okay, now lots of people have asked me how to get these amplifiers powered up on the bench. You need to pulse the remote. Okay, so what I've got now is I'm trying to turn the amplifier on. I'm limiting the input to this amplifier. I'm going to give it about 8 amps. So it can't suck any more than 8 amps from my supply. You notice that when I hit the remote, I get flashing blue light and the clip light. And that's telling me that basically there's not enough current available for the amplifier to come on. So what you've got to do is you've got to keep pulsing the remote. Every time I hit the remote, it builds a little bit more rail voltage. Can you see that? Every time I hit the remote, it's just pumping it up a little bit more, but more and more, bit by bit every time. And eventually, it'll get to the point where the amplifier is happy with the rail voltage and it will actually come on fully. Up at 90 volts on the rail, 100 volts. Okay, now we're at the point where the amplifier is happy and it's going to power up. It's going to come on. And as you can see there, right, this is why these amplifiers are so hecking dangerous, right, for inexperienced users. The amplifier is off, okay? The amplifier is not powered on. On the speaker terminals, there is 120 volts DC, okay? The amp's not even on. 120 volts DC. Don't touch that, okay? It's fucking stupid design, this. This is one of the reasons I prefer the Taramps design and I prefer the Powerhouse design and Banda. Oh no, actually Banda's just the same as this. Banda sucks in this case. But yes, the Taramps and the Powerhouse design doesn't hold the DC half rail on the speaker terminals when the amplifier is not powered. Oh, hey, actually, I think this is not right. I think this is actually showing me a problem here. So basically, on these amplifiers, we shouldn't have. Okay, that's a problem. Yeah. Okay. So I haven't even powered the amplifier up fully yet, but I think I see a problem. Basically, on the high side of these amplifiers, what we should have is we should have full rail on pin 2, which is the middle one here. On pins 1 and 3, we should have something like half rail or a little bit less, maybe like a third of the rail. So where we've got about 100 volts on the rail there, on pin 1 and 3, we probably should have about 40 volts, not 100 volts. Now we checked the MOSFETs earlier, none of them were shorted, so this might happen if the MOSFETs were shorted. None of the MOSFETs were shorted, so something else is causing the rail voltage to leak onto the high side source and high side gate. So we need to go investigating what that is, I think, because yeah, I don't think this amplifier is going to want to power on. It's tempting to try and power it up anyway, see what happens. But yeah, I suspect it's probably just going to go into protect or something like that. Let's have a look. Let's probe the low side drain and see what happens. Okay, nothing at all. So the lights on the amplifier are showing solid blue and clip. We just have full rail on the low side drain and no switching. So the amplifier is not attempting to switch the FETs. We just have full positive rail on the low side drain, which is absolutely not correct. So yeah, something has failed. It's likely to be something in the drive circuit over here. Have a great day, Jesse. Hope your thing goes well. Thanks for jumping on. Yeah, it's cool having such a high voltage here is cool, but obviously the current is lower. The current that is generally accepted that you can draw from each socket is about 13 amps. And the ring main limit, so the limit for a ring is about 30 amps. So I'm sure you could probably pull more than that, but so what I need to do now is wait for the voltage in this big thing to sink down to ground, and then we can have a look at the drive circuit and see what's going on. What I'm probably going to do is I'm probably going to put this amplifier into service mode. So if you've never done that, there we go, nearish, just said that as well. Yeah, probably going to put this amp into service mode, and that will help us to diagnose the issue a lot safer without the massive crazy high voltage there. So greetings from Austria. How's it going, Stefan? Good to see you, buddy. When you film your next boom or bust, can you show us a little of that giant printer doing its thing? Maybe. I already did print the box for number 2, for episode 2, so I can't show you that one. But episode 3, yeah, maybe. I actually did mean to set up a time lapse, but I completely forgot. So sorry about that. But, yes, I'll try and set up a time lapse of the next box being printed, because that will look really cool for sure. I'm good. I'm glad that you guys are excited for Boom or Bust. It's going to be good. Some time-lapse footage is good filler content for Boom or Bust. Yeah, true. I don't want the episodes to be too long though. I want to try and keep them watchable, keep them between 20 and 30 minutes maximum, I'd say. Wow, this is taking a long time for that voltage to sink down. What I would usually do is I would usually use my wires here to thank you so much, very good, thank you very much. I'd usually use my dummy load bank here to sink the rails down to ground. However, I'm using my dummy load bank to load the amplifier terminals, and they still have 100 volts on them, so I don't want to go removing them from the terminals, because I'd need to touch the metal Allen key in order to remove them, and I'd probably feel 100 volts DC. Someone said connect a camera to one of the motors on the printer. I could connect a camera to the hot end. That's a pretty cool idea. Yeah, that would actually look really cool, and do a time lapse. Have you repaired any of the 4-bridge amps from Alibaba? Same. Well, yeah, it's the same circuit, so yeah. I haven't repaired any of those ones with that sticker on the front, but it's the same. Repaired hundreds of them. 3D printing is indeed fascinating. What boggles my mind is their accuracy, which is extremely precise for something that moves so fast. Yeah, absolutely. Stepper motors are pretty awesome things, and it's pretty cool how accurate they are as well for the price. Like, 3D printers are not that expensive. They're easily accessible for almost any hobbyist, really, at this point. You know, a few $100. Yeah, sure, you can easily save that up in a couple of months most of the time. Cut out on some other thing that you like a lot. Cut out on drink maybe for a couple of months to save up, or eating out, or there's lots of things you could cut back on for a short period of time. Save up some money. 3D printer, boom. Now you have the ability to basically make anything you want. It's a massive freedom thing. It's a massive flexibility thing. Like having a 3D printer, yeah, it's freaking awesome. Something breaks, something random and specific breaks that you've got. Print a new one. Awesome. 3D printing is getting way bigger. I've got an Ender 3. I have 3 Ender 3s in my living room, and I've been working on a 6-inch door pod. Nice. 3 and 3s in your living room. That's one way to do it. Amazing. Your end of work day and beginning of mine are identical. 9 AM here in California. Was awesome to realize you're talking amps at breakfast time. Yeah, man, that's awesome. Yeah, I'm streaming a bit earlier these days than I used to. Sam, you should make some 3D printed speakers, like some proper full-size desktop speakers, and use them to edit Boomer Bus videos. Absolutely. I've definitely got a few ideas in my head of some speakers that I would love to make, and I just need to get some time, sit down on Fusion 360 and design them. Absolutely. I actually have too many speakers at the moment, as in like desktop speakers that I know what to do with. I've got some pretty nice sounding speakers in here. They're not super high end, but they sound really, really great. They image beautifully in the workshop. I've got lovely Martin Logan speakers in the lounge. I've got some really good monitor. I can't remember what the brand is. I've got some nice speakers in the kitchen. Yeah, I've got nice speakers around the house generally, but I always try and find an excuse to build some more. You know how it goes. But yeah, definitely got some ideas for some nice 3D printed speakers for sure. Yes, the supports can be a nightmare. If you're the thing that you want to print has like massive overhangs and stuff, it can be a nightmare working out how the hell to print it with supports. Maybe sometimes the best thing to do is just to slice the model in half or in a way that makes it easy to print in 2 parts and glue them together. Sam, 3D print a cold air intake for the yellow car. It's not a bad idea. The Proton did actually come with a cold air intake like tube right from under the grill, but in my infinite wisdom when I was 18 decided to remove it and fit a cone filter instead because it sounded better. But yeah, stupid. Definitely impacted the performance. 3D printers are very cheap for how handy they can be. Absolutely. Yeah, the amount you can do with a 3D printer is a lot for how much they are. You're already learning Fusion. I started that and Tinkercad. Yeah, Fusion 360 definitely seems pretty good so far. I sincerely hope they have quiet boards installed. Otherwise, the noise from 3 running would be... Yeah, the Enders are not the quietest things from factory. My one doesn't have the quiet board and it is quite noisy. I can imagine 3 of them going together would be absolutely mind-numbingly loud. By the way, Hexibase apparently just released a new video, so you should all go watch that after my stream. Some they have water-soluble support material. You use jaw extruders when doing that. It's pretty handy. I've definitely seen that. Yes, really cool. I think definitely at some point in my future, a dual extruder printer is definitely right up my alley. Being able to print something with crazy supports and then just have it disappear in water afterwards. Absolute game changer. But yeah, for dipping my toes in the 3D printer world, this Ender 5 Plus I've got here was literally just down the road from me where I live. It was a really great price and it came with 11 rolls of filament included in the price. So I thought that's good to get me started. That'll do me. Right, how's the voltage in this amp looking then? Is it dipped down at all? I should have more than one load bank really. Okay, we're at 46 volts. That's alright, that's fine. That's safe enough for me to take my Allen key here and undo the speaker terminals here. Shouldn't tingle too much. That's one. That's 2. Okay, so now I've got my load bank disconnected from the terminals. I can use it to discharge the caps inside. Yeah, just put one wire on the case, which is ground, and touch the other one on one of the high side drains over here. Well, I could probably just touch it on one of the rectifiers actually, that'd be alright. There we go. Should now be all that rail voltage dissipated through the load bank. Yep, cool. Right, so just real quick, I'm going to show you guys how to put these amps into service mode. So, to get these big amps into service mode, it makes them much easier to work on, much safer to repair, no high voltage rails anymore after putting it in service mode. Yeah, it just reduces the risk of further damage and reduces the risk of damaging yourself as well. So first thing we need to do is turn the hot air gun on, get our hot air station heated up. And what we need to do is we need to prevent the power supply section from oscillating. So to do that, depending on what amplifier this is, we might have to either remove the power supply driver, which is this one, or remove a couple of resistors in line with the PWM to the driver. So in this amp, looks like we have a couple of 100 ohm resistors that go between the pick, which generates the pulses, and the driver. So we can go ahead and remove the 100 ohm resistors, and not only is that easier than removing the driver chip, but it also is much safer for the power supply FETs, because the power supply FETs in this amp, actually not these ones don't, but sometimes in these amplifiers the power supply FETs use the driver as a pull down for the gates to prevent the FETs from spontaneously turning on, phantomly turning on. So if you remove the driver, sometimes the power supply FETs can just magically turn on by themselves and die. So we don't want that to happen. But yeah, in this amplifier there's a couple of 100 ohm resistors here that we need to remove. So that stops the power supply from oscillating. Once we've done that, we need to then trick the pick into thinking that it has the high voltage rails present. And to do that, we just have to feed it with the voltage it would normally get from the rails stepped down through a voltage divider. So the voltage divider for the rail voltage that's sent to the pick is, I think on this one, I think it goes through this resistor here, then this one into pin 14 of the pick. I think that's how this works. Let's double check. So we have rail voltage on the high side drain over here. So we should have rail voltage here. Yep, there it is. There's rail voltage on that resistor. So then we go through this resistor into this one, out of this one into this one, out of this one into pin 14. So that's our voltage divider, and that's how the pick knows how much rail voltage is present without basically killing the chip. So in order to trick the pick into thinking it's got rail voltage present, all we need to do is remove this 10 ohm resistor, which is the final one in the series of voltage dividers. Remove that one, which takes away the connection to the rail. And then we need to jump over from VCC, which is on pin 1, and conveniently this pad here, connect this to pin 14 through a resistor, like a 5.6K, in order to calibrate the correct voltage on pin 14. So let's get started with that. Once you've done that, the amplifier will power up, and it'll think that everything's okay, and it'll try and switch the output FETs. So a bit of flux on these resistors here, and a little bit on this pad. And we're also going to connect pin 14. Instead of soldering directly to pin 14, which is a little bit tricky, we're going to solder to a larger component that also has continuity with it. So we're going to solder to C23 over here. So a little bit of flux on C23 there. Cool. That's one. That's disconnected the rail from the pick. Now we need to disconnect both sides of the pulses. There we go. And now we just need to connect a resistor between VCC and pin 14. So for that, I've just got this little potentiometer here. This is a 50k. So what I'm going to do is bridge these together to turn it into a 25k. Probably just make it a little bit easier for me to set a resistance of about 5.6k, which is about the resistance that it needs from memory. Billy says, Sam, you should use an incandescent bulb for shorting the rails with probes attached. I use a mains voltage light bulb for this. When the light goes out, then it's down. That's a great idea, actually, yeah. I might try that. Yeah, that's a really good idea, because then obviously you know that the rails are discharged when the light goes out. That's a pretty cool idea. I might try that. But for amplifiers that have like 400 volts worth of rail potential, would obviously need a bulb that could deal with that much voltage. Maybe 2 bulbs in series actually might work. Sam, have you ever messed with Pro Audio horn loaded boxes? The output is killer, but they're very large. Yeah, I'm a massive fan of tapped horns. I think they sound really fucking awesome. But I don't own any of my own yet, but I would love to own one. I want to actually have one made for my 6.5 inch digital designs, my 1506. That would be freaking awesome. In these amps, does the PIC provide the PWM to pin 3 and 4 of the 20957S? No, it doesn't. No, the PIC is just power supply, PWM, protection, and yeah, muting. I think that's it. It doesn't actually provide the any clock for the output side, I don't think. Could be wrong, but I'm pretty sure it doesn't provide a clock for the output side. Okay, cool. So now we just need to connect this. Actually, I'm going to calibrate the resistance of this first. So yeah, we want about 5.6k from memory. It does change depending on what model of amplifier it is. Like the bigger ones or the smaller ones might need more or less resistance between VCC and the rail for pin 14. Let's have a look. So what have we got on this one at the moment? Okay, it's more than 20k, so let's turn that down. What the heck? Why am I not reading anything on this? Right, there we go. So let's start to turn it up a little bit. There's 2.4k, a little bit more. 8.2, down a little bit. 5.4, that's probably alright. 5.4k, that's probably fine. So yeah, just need to tack one side of this onto C23. And the other side goes onto this handy pad on the board here. Okay, cool. There she is. So now we should be able to power the amplifier up, and it won't generate any high voltage rails because it doesn't have the power supply oscillating, but the PIC should think that everything's okay. So provided we've done this correctly, when I apply the remote to the amplifier, it should come on with the same fault mode that we observed earlier with full rail. So we should have blue LED and clip light solid. If we have a flashing blue LED, it means the amplifier thinks the rails aren't high enough or that they're too high. Okay, cool. Yep, solid, clip and power. Ah! Although we do have some PWM now. Oh wow, we're drawing a lot of current. Holy crumbs. We were drawing a full 8 amps there. So, okay. It's not doing that anymore. What about if I give it a bit more voltage? 12 volts. So the only thing different really, apart from it being in service mode, is I don't have a load on the speaker terminals this time. That might have been the filter network breaking down, as I explained earlier. But this amp shouldn't be doing any switching. Oh, there we go. See, now it's drawing a lot of current. It's drawing like 4.5 amps. It's trying heavily to switch. Both sides are trying to switch, but doing something really strange. They're kind of failing to switch correctly, and the whole thing is drawing a butt ton of current. What I'm going to do is I'm going to connect my dummy load back up to the speaker terminals here. See if that changes the behavior of that at all. It does. It changes how the PWM looks on the scope. Looks a bit different now, but it's still drawing a lot of current. So definitely not happy. And I'm actually quite pleased that it didn't try and do this while it had high voltage rails present, because we might have killed some FETs. I don't think we've got any dead FETs yet. That's the thing. So I don't think any of the FETs are actually dead. I think we've got a drive circuit fault. Yeah, as you can see, on the low side drain, we have basically full rail voltage there. Actually, it's a little less than full rail voltage, but it's pretty much full rail voltage. And that should be about half rail, or less than half rail. So yeah, definitely the problem is present on the board, even though we don't have the remote. You know, the amplifier's not trying to power up. So it's going to be some kind of component that is leaking. Leaking onto the low side. Thermal camera. People are asking for the thermal camera. I think that the components that are getting hot are going to be the MOSFETs, which are clamped to the heatsink. I think they're going to be getting hot because the frequency that is being sent through the inductor here is too high or something. So I think the inductors aren't really doing their job properly. Let's see what we got on the speaker terminals. So on the speaker terminals, we've got this 37 Hertz. Oh, hey, that's actually because I've got some signal going in. Ah, I forgot I had the RCA connected. So if I remove the RCA, now we're idling at 5 amps. Although it does jump up, it's very, very high idle current. Okay. Wow, 10 amps. Holy. Yeah, okay. Let's see if anything's getting hot on the board here. Let's get the thermal imager. Okay, wow, we definitely have something heating up in the drive circuit here, yes. think it's the, is it the driver? Is it the drive IC that's heating up? Hard to tell. I'm going to grab some isopropyl alcohol, I think, and see, although, see if I can get a better... In service mode should be about 1 amp. Yeah, I agree. Absolutely. Right. Let's get this powered back up again. 5.66 amps. Okay, what's getting hot? 47, 58, 54, 62. It does look to me like it's the drive IC, although actually no. It's slightly to the right of the drive IC. It looks like it might be the drive buffers. IC13, IC14 I think might be the things that are getting hot there. This thermal imager is actually not very good. It's the visual image is offset from the thermal image a little bit due to the position of the cameras. So you can see the thermal cameras there and the main cameras up here, or vice versa. So in order to work out which component in a small set of components is getting hot, you have to kind of shift it to the side and see where it lines up with. Okay. It looks like it is the drive buffer over here, IC14. That looks like the one that's getting super hot right now. Let's go ahead and turn the power supply off, drain the rails, and let's probe some resistance values around the area, see if anything is like shorted out over there. What does it mean when the clip and power light stay solid? It means that Class D switching has failed to build due to an output circuit fault or drive circuit fault. So here we have IC14. So we have ground on that pin there. Okay, yep, I think that's correct. Ground on there. Okay, those readings seem to be looking okay so far. These diodes are quite common to fail. These, I think they're 5.6 volt Zeners, or they might be 15 volt Zeners. I can't remember off the top of my head. But yeah, these diodes can often fail. So let's check these. Seem okay so far. Okay. It can also be quite common for the 15 volt Zeners over here by the FETs themselves to fail. So I'm just going to go ahead and check the diodes over by the FETs. I'm thinking it could be one of these because we have too high of a voltage on the low side drain when the amplifier is powered up. 430. Okay. 446. Scratch away at this glue here that's in the way. 466. 466. 466. 466. 492. Sorry, 592. 622. 622. What about this side? Okay, so at the moment, all the signs are pointing at potentially a bad final drive buffer. Little 6-pin IC here on the output side, I think. Yeah. So I think that at the moment, all signs are pointing at this little drive buffer, this IC14. So is that the low side or the high side one? That is the low side one. Oh hey, actually, you know what? I think I did miss a bad MOSFET. I think I missed a bad FET. Take a look over here on the output section. This high side bank over here, I think I must have missed a bad MOSFET over here. There's 800, 9. Okay, so none of them read bad gate to source, but reading between gate and drain gives us a low resistance. So that was my bad. I just didn't check these thoroughly enough. Almost 9 times out of 10 when a MOSFET fails, it will go short, low resistance between gate and source. So when I'm checking FETs, often I'll just very quickly just check the outer two legs. And if there's any low resistances there, then obviously there's a problem. But see here, we have 27 between gate and drain. 71 there. 71. That could just be reading the bad MOSFET in parallel with the rest of them. 71. 71. Okay, so this one MOSFET up here has the lowest resistance between gate and drain. So that's interesting. So what I'm going to do is, just to isolate that MOSFET from the circuit, I'm just going to pull the gate resistor off of its pads, and if the low resistance disappears from the rest of the FETs and stays on this one, then we know that it's a MOSFET issue, not a drive circuit issue. But yeah, I think that that might just be the case, that it killed one MOSFET. And this can actually happen on these amplifiers when the amp is powered up without having a load on the speaker terminals. Very common, because the filter network breaks down and stresses all the output FETs. So all I need to do is just shift the gate resistor off its pad here, and that will just confirm for us that this is the MOSFET that's bad and not something else we're reading in the circuit. Where did I put my good tweezers? Here they are. I found them. Okay. So let's check again then with that gate resistor shifted. So yeah, we have 27 between gate and drain. And on all of the other MOSFETs, we now don't have that low resistance. So I think this amp just killed a single FET here. So yeah, let's cut that one out. Get that out of the circuit, and then we can power the amplifier up again with this one out of the circuit to confirm whether the rest of the drive circuit and everything is okay, which I think it probably is. Okay, so now we just need to power it up and see if the drive circuit's okay. So we've got 12.6 volts going in. service mode, so no high voltage rails, bit of RCA signal as well going in. So let's power it up and check for switching. See, now we only have 3.7 volts on the low side drain as opposed to pretty much full rail, which is what was showing up on there before. Okay, cool. There is some nice clean output switching with 0.7 amps worth of idle current draw at 12.6 volts input on both sides. So yeah, good news is the drive circuit is a-okay. Good to see. Yeah, just lost one MOSFET. So the thing about that is that's going to be one that I'm going to have to ask the client what they want to do, because this amplifier's killed one MOSFET. Now usually you would never ever replace either just a single dead FET or like a bank of FETs. You'd want to replace all of them in this side. This amplifier is a full bridge, so we have one amplifier here, high side, low side, high side, low side. So the absolute best thing you could do would be to replace all of the output FETs, which would be very expensive repair. These 4227s are like freaking expensive AF at the moment. The next best thing to do would be to replace just this half, a bit cheaper. The next best thing to do would be to replace just the high side bank, with the worst thing being to do just replacing this single one dead MOSFET here. And if you were gonna go for replacing just a single dead MOSFET, if this is your own amplifier, for example, and it's not a customer repair, and you're like, oh, I'll just try changing one MOSFET. Must be the same bank. If it's not the same, must be the same batch of MOSFETs. If it's not the same batch, then you need to remove at least one or two in the same bank and confirm with a transistor tester like this that the FET you're replacing matches VT, CGS and RDS with the pre-existing MOSFETs. If it does, then you might have good luck replacing just one MOSFET. But that doesn't mean to say that the other MOSFETs in this bank haven't been stressed by whatever caused that one to die. So these ones might be on their way out as well, might only last a few hours, might fail once they start heating up. So always best idea to replace all the MOSFETs if you can, or start working your way back through those less than ideal things. If you can't replace all of them because it's too expensive, replace just that ones. If you're not going to replace just those ones, replace just the bank. And if you really can't replace just a bank, and you just want to replace one, then check it first. Only do it if it's your own amplifier, never for a customer. So the options I'm going to give the client on this are change all the output FETs for very expensive, change just one side, or change just the bank. I'm not going to give them the option of the single FET replacement because that's too much chance of failure again soon after with that one. Daniel Doré says, can you tell me what IC15 is on that board? IC15, where's IC15? IC9, IC3, IC1, IC7, IC12, 13, 14, IC6. Oh, IC15. IC15 is a buck converter. So I actually tell you what that chip is in my old video called So You Want to Repair Sound Digital Amplifiers. So go to YouTube, type in BearVids, repair sound digital. Watch that video and I tell you in that video what the buck converter is. I can't remember the model number off the top of my head. Maybe Neeresh will tell you in the live chat. But yeah, I can't remember the model number. Alright, cool. I think that's about wrapped it up for today. Thanks for keeping me company on the stream. As always, it's always good to stream my repairs with you guys. Makes it a bit more interesting, a bit more fun. So yeah, appreciate you guys coming along and hanging out with me while I look at these amps. Stay tuned for Boomer Bust 2. Boomer Bust episode 2 is coming soon. I have printed the box already. It's going to be fun. And take it easy, guys. Take care. Any questions, give me a shout on BearVid's Facebook page. And I'll see you in the next one. Bye-bye. Oh yes, and watch Hexibase's new video. I haven't watched it yet, but apparently it's